There are several commissioning certifying organizations that provide training and allow students to be certified as commissioning specialists. In this video, I'll explain the different types of commissioning certifications and which one is the best for you. There are two classifications of commissioning certification depending on the type of commissioning you are involved in. They are building commissioning and industrial process commissioning. And you will want to make sure you are pursuing the correct certification because there are similarities and differences for each of these classifications that will determine the commissioning process you will follow. The building commissioning process applies to these types of facilities: commercial buildings, warehouse facilities, high-rise residential buildings, high-rise office buildings, airports, data centers, malls, arenas, stadiums, and museums. And building commissioning is made up of these types of subsystems: auxiliary power systems, HVAC, smoke management systems, fire alarm systems, fire sprinkler systems, fire shutters, fire dampers, lighting control systems, elevators and escalators, solar shading control, IT LAN systems, security control and monitoring, building management systems, really all life safety systems to obtain the building occupancy permit. The building commissioning process is quite common since there are several facilities like these that I have listed. The industrial commissioning process is a bit more complex and applies to these types of facilities: onshore and offshore oil and gas facilities, LNG processing plants, manufacturing facilities, food processing facilities, power transmission substations, transmission distribution HVDC converters, power generation plants including hydraulic generation, gas turbine generation, coal generation, nuclear generation, renewable energy such as solar, wind, or biomass, water treatment facilities, wastewater treatment facilities, mining and ore processing sites. There are several similarities between the building commissioning process and the industrial commissioning process, but there are some distinct differences to be aware of, which I will describe. Some of the similarities are that the process and phases of commissioning are somewhat similar. In both commissioning processes, the same sequence of activities are required for pre-commissioning, commissioning, and startup. Another similarity is the need for an independent commissioning provider. In both cases, the commissioning agent or authority should be a separate group from the design group and the construction or installation group. This is to ensure that the same group is not also responsible for verifying their own work. This is a conflict of interest, like having the fox guard the henhouse. The construction or installation phase of both commissioning processes is very similar. The vendors and contractors need to install what is detailed on the IFC drawings and ensure that their installations meet the quality requirements of the contract. Now, like I mentioned, there are some differences between the building commissioning process and the industrial commissioning process that you need to be aware of. These differences are important as they change the thought process of how contracts are structured and how the project comes together in the end to align with the end user's needs. The standards and guidelines are somewhat different for both processes. The building commissioning industry is well documented with standards to reference on how commissioning requirements are to be met. However, the industrial commissioning process is not well defined at all. There are really only two standards related to the industrial commissioning process, being OPRACOM, which is a proprietary set of documents prepared by Total, specific to the oil and gas industry. These documents are extensive, but since they're proprietary to Total's internal processes, they're really not available for use within the industry unless working on a Total project. Now, the other set of documents is from API, which is a set of documents issued by the American Petroleum Institute specific to the oil and gas industry. API RP1FSC is the document outlining the commissioning process. However, it does not provide a lot of detail and provides the theory of commissioning rather than the process to be followed for a practical approach to plan and execute commissioning on site. Another difference between the two commissioning processes is the terminology used in both processes, which is probably the most confusing part of the commissioning industry. While similar, the specific terms used are different and can be confusing for someone new to the commissioning process or someone who is transitioning from building commissioning to industrial commissioning, since the terminology is different. Even within each classification, the terminology used can be different from project to project, since each contract can define different terminology to use. And the terminology is important, since the details matter during commissioning. Using generic terminology or conflicting terminology can be quite confusing to everyone on the project when discussing the details of commissioning. Another important distinction between building commissioning and industrial process commissioning is related to brownfield projects. Upgrading or expanding an existing facility during industrial process commissioning adds a whole other level of complexity that doesn't exist during building commissioning or even during commissioning of greenfield industrial commissioning processes. A building can certainly be upgraded or expanded, but usually does not involve critical in-service assets that cannot be disrupted. For example, during brownfield industrial process commissioning, an existing power substation must stay energized so that customer power is not disrupted. Another example, the flows to a wastewater treatment plant cannot be shut off, and the plant process must continue to treat waste streams while the plant is being upgraded. Because of this, working on a brownfield project, particularly during commissioning, must be precisely planned and executed to coordinate with in-service assets. Activities take much longer because of this, and these logistics must be accounted for in commissioning plans. Off-site testing during factory acceptance testing and integrated factory acceptance testing is much different between building commissioning and industrial process commissioning. Much of the equipment supplied for building projects is commercial off-the-shelf devices. For example, the fire control panel is a standard device to be interfaced to other components of the fire protection system. For these off-the-shelf components, very little oversight is required for testing in the factory of these items, since it has been done many times and the vendors are well established with their manufacturing and testing processes. However, for industrial process systems, there are many custom designed components. For example, the control and protection cubicles for monitoring and controlling an AC switchyard are custom designs with custom PLC cubicles and interfaces that are designed and manufactured off-site. Because of this, this equipment needs to be extensively tested in the factory to confirm that there are no design defects and no manufacturing defects. A lot of this equipment includes custom PLC logic for control and monitoring of plant processes that needs to be verified in the factory as well. Since the logic code is a fundamental design element of the control and protection cubicle, they both need to be tested during integrated factory acceptance testing before being shipped to site. Because of this more complex equipment specific to industrial plant processes, special attention needs to be taken to testing in the factory to ensure this equipment functions as specified before it arrives at site. It is too late in the commissioning process to test and integrate this equipment. As would be done during building commissioning, there needs to be an advanced approach to test and integrate these complex devices in the factory to ensure on-site testing during industrial process commissioning goes smoothly. Another difference between building commissioning and industrial process commissioning is the level of subsystem interdependency. Many of the subsystems in building systems are largely standalone. Building subsystems do not depend greatly on other subsystems, besides the obvious ones such as power required to test other subsystems. There are very minimal interfaces that exist between building systems. For example, a single interface between the smoke management system and the HVAC system may exist, but for the most part, systems are standalone. The lighting control system does not depend on the fire sprinkler system. The solar shade system does not depend on the security system. However, this is not the case for industrial process systems. For example, the mechanical pipes, valves, flow meters, pressure sensors aren't much use without the instrumentation to monitor the process flows. The instruments aren't much use without the electrical system to interface these devices to the PLC. The electrical interfaces aren't much use either without the PLC controllers to communicate with the instruments and end devices for control of the plant process. Everything works together and is integrated as one plant process. Because of these interdependencies, commissioning becomes much more complex in planning and executing activities. You cannot proceed to commission one system unless the required prerequisite system is available and functioning correctly. There is often only one sequence of commissioning activities you can proceed through due to the technical interdependencies of one system on another. This means that industrial process commissioning must be precisely planned in advance with construction deliverables that align with the required sequence so that commissioning can proceed without delays. This is a significant task that can take quite some time to prepare for, much different than planning for building commissioning, since there is much less to plan for on-site commissioning of the security system other than it needs to be installed with power and the vendor needs to arrive on a specific date. Building occupancy is different for building commissioning and industrial process commissioning. The goal during building commissioning is to achieve building occupancy. This would indicate the end of the project with a few items to monitor and adjust once the building is in service. For industrial process commissioning, building occupancy signifies the beginning of commissioning. The building is often the first part of the project required for industrial process commissioning. For example, the building enclosure with life safety systems such as HVAC, lighting, fire detection and protection is required to obtain building occupancy, or at least interim building occupancy, before installation of the process equipment can take place prior to commissioning. In the example of an electrical HVDC facility, the valve halls are required prior to the converter assemblies being installed, interconnected, and commissioned. In the case of a mechanical facility, the building enclosure with fire protection is required before the pipes, pumps, motors, valves, and treatment equipment can be installed and tested. Operations and maintenance is also slightly different in the two different classifications. There is maintenance required for both classifications of projects, but there is much more significant operations required for industrial plant processes. As an example, there will be maintenance staff on site for both types of facilities, but a building would rarely have on-site operators to monitor and control the facilities. A facility such as an oil and gas platform or a wastewater treatment plant will have on-site staff during the day and often overnight staff to monitor and control the plant process. This changes the game during commissioning in how facilities are started up for the first time. Industrial plant processes are often controlled from a central control room or even an off-site control facility, and this is a central part of commissioning industrial plant processes. In building commissioning, the fire control panel will operate with no intervention. However, industrial plant processes may require periodic intervention by operators as alerted by the SCADA or DCS systems. Because of this, it is critically important to ensure that the HMI systems, the plant operator's primary point of contact with the plant processes, functions correctly and can be relied upon for monitoring and controlling the plant facility. These are complex systems requiring detailed attention during commissioning. Because of the critical aspects of these complex systems, operational readiness becomes important during commissioning of industrial plant processes to ensure a smooth handover from project to operating teams. Now, when it comes to operational readiness, this is an important topic leading up to the in-service date of industrial plant processes. Due to the complex nature of industrial plant processes, the operating staff require guidance and support to ensure they are ready for ongoing operation and maintenance of the new facilities at the in-service date. It is not appropriate for the project team to abandon site at the in-service date and leave operators looking around wondering what to do with the systems. Close coordination and collaboration between operating teams and commissioning teams is required for industrial plant processes. In fact, commissioning is the best time for operators to see the systems, get hands-on experience, ask the equipment experts on the commissioning team any questions they have to become familiar with the site, and get a level of comfort leading up to the in-service date. This doesn't necessarily exist for building commissioning since there is less of an operational requirement, and the lighting control system does not require a lot of intervention or oversight by operators. The tasks for operational readiness, such as setting up equipment asset management systems, training operators, and preparing the operational documentation, need to be focused on for industrial plant processes to ensure a smooth handover from the project to operations. As you can see, there are some important differences between building commissioning and industrial process commissioning. While the processes are similar, you can see that there are some more complex elements to consider in the industrial commissioning process to ensure that the project ends successfully. From the list of building commissioning certifications, you can see that the industry has many certifications to choose from. But can you believe there is no certification for industrial process commissioning? This is something that the industry is working on, but this is not currently available yet. And you can see from the differences we discussed, commissioning of industrial processes is much more complex than commissioning of building systems. Commissioning of HVAC systems is very common and pretty basic compared to commissioning of oil and gas refinery processes. So without a governing body to provide certification for commissioning of industrial plant processes, what do? Where do you go to learn and understand the structured and organized commissioning process for industrial systems? Your best source for industrial process commissioning is right here at the Commissioning Academy. We offer full system commissioning training that shows you the detailed steps to follow to implement your complex industrial plant process in a structured and organized way in an easy to follow sequence of activities to complete your project on time and on budget. And best of all, you can get started with our training for free. Get started with our free 3-day mini course that gives you an overview of the structured commissioning process to follow. Go to www.commissioningandstartup.com or click on the link in the description to get started now. Once you complete the mini course, we'll send you access to the first part of our 6-part full training program where you can choose to continue with our full training to learn all the details of industrial process commissioning.